Hi everyone, today we're doing something quite different. We're doing a Hack the Box Academy module. We're doing attacking web application with FFUF. So we're gonna go through at least the introduction to all of the basic fuzzing. Then the next video will be about domain fuzzing, and the final video will be just doing perimeter fuzzing and the skill assessment. You can see that I haven't done that yet, and I'll probably do this after the video I'm recording right now. So let's get into it. So we can see here, introduction. Welcome to attacking web applications with FFUF module. There are many tools and methods to utilize directory, parameter fuzzing, and brute forcing. We will mainly cover FFUF, web fuzzing, and the most common reliable tools for web fuzzing. We can see web directory fuzzing, web directory fuzzing, files and extension fuzzing, and identified hidden vhosts, and fuzzing for PHP parameters, fuzzing for parameters as well, parameter values. So tools such as FFUF provides a handy automated way to scan pretty much web applications and individual components of website. This means, for example, we can use send request to web server, see if a page exists on the web server, and if you get page a code 200 which tells us it exists, then we know this page exists on a web server and we can look at it manually. So we could do, so say if we get this as a response, this whole web URL, we will probably get a web response of 200 which tells us that it exists. 404 is not found, and 500 is an internal server error. And if we ever get a internal server error, it could always be used as an SQL exploit. I'll try to describe that later on, hopefully in this video. So we're gonna move on to the second page here. Web fuzzing. We will start by learning the basics of FFUF, to fuzz websites and web directories. We will run this exercise in the question below. Visit the URL and it gives us the following website. So we can see here the website has no links to anything, nor does it give us any information that could lead us to more pages. So it looks like our only option is to fuzz the website. So fuzzing is a term that refers to testing techniques that send various types of user input to certain websites to study how it reacts. So if we were studying for SQL injections, we would be sending random special characters to see how the server reacts. So a great example of this would just be a login form on a website. You can probably just send a single quote like this. Sorry if this is not that clear, but you can see here a single quote. So if we just send a single quote to web server and we send it and we capture the request in burp speed and we get a 500 return internal server error, it tells us that it's executing an SQL. Executing SQL on the front end of the website, which is very dangerous, which can lead us to suspect that there's more, we can do an SQL injection as the input wasn't handled properly. So we can see here, we've read this, so if we were fuzzing for a buffer overflow, we'd be sending long strings and just see what would happen. Would the binaries break and when? So we usually utilize predefined word list of commonly used terms for each type of test for web fuzzing to see if the server would accept them. This is done because web servers do not provide directories of all available links or domains, so we can check for various links and see which ones return pages. We can see here Hack the Box EU does not exist. This would return a 404, which we can see here, which tells us that it is not found. So we can see, however, if we we go to a page like login, we get a login page and a HTTP code of 200, which we can see below here. So we can see that this is the basic idea for web fuzzing, and for pages and directory we still cannot do this manually. It will take forever. This is why we have tools that automatically do this efficiently and effectively, such as hundreds of requests every second. Study the HTTP code and determine whether the page exists or not. We can quickly determine what pages exist and then manually examine them to see their content. So we can see here, word list to determine which pages exist. We should have a word list containing commonly used words for the web directories and pages. Very similar to a password directory attack. So we can see this will be discussed in a later module. So this will not really reveal any pages under a specific website, as some pages are randomly named and use unique names, which is good, which can stop brute forcing web directories, as it's unlikely that it appear in the brute force attack. So I want to show quickly of one that we can use. So if I open this here quickly, we'll open my command prompt. Hopefully it opens quickly. So if we navigate to user share word list dirbuster and we go to directory, dirbuster, let's just go there quickly. Actually, let me just ls user share word list. Share word list. This is where a lot of words will be stored. You can see here dirbuster is one of them that comes pre-configured with Kali Linux. So if we do ls, we can see here we have lots of shoots, and I want to show you a specific word list that's very commonly used because it's very effective. One of them's here, directory list small.txt. So you can see here this is containing a bunch of directories that can be used within the website that can be fuzzed. And it's unlikely, if you have numbers, if you contain numbers or you just name it very weirdly, it's unlikely that this would pop up. So we can see here, passwords attack we discussed in a later module. So we can see GitHub is mostly commonly found word list. So the seclist is a good one. I have seclist installed, which categorizes word list under various types of fuzzing, even including commonly used password, which we'll utilize for password brute forcing. Within our pawn box, we can utilize the entire seclist repo with available under opt useful seclist. The specific word list we'll be using for utilizing the pages and or directory fuzzing commonly used called this one, this which I just showed here, and it is available in very different forms and sizes. If you're in a tac box, it'll probably be there, but for me, and it may be for you, my seclist is stored here. Use a shared seclist. And if I ls this, you can see here that it has lots of things which we mostly be using the fuzzing and the discovery sections of seclists, as that's probably where we'll mostly be using in this module for. So we're gonna let this load for a bit. So we're on the directory fuzzing page. Now that we understand the basic concept of fuzzing and we know our word list, we'll start using fuzz. Well, for FFUF. So FFUF is pre-installed in your pawn box, but if it isn't, you can use this to install it, or you can download it from GitHub. As a new user of the tool, we'll start using FFUF.h to see how the tool works. So we can see here that it has a bunch of options which you can use. The help output is quite large and it's kept the options that may become relevant for us in this module. So we can see from the example above, W is for word list, U is for URL. We can assign different word lists to the the W variable, and the U variable can be our URL that we're going to use. So we can use the keyword fuzz, pardon fuzz after it. But I'm pretty sure this is a pretty outdated, I'm going to be honest. You don't need to use the fuzz key term, and I very rarely see anyone use that at all, except from outside this module, which is a bit strange. But one that is mandatory is within the URL, you have the fuzz. This is a placeholder that just tells the FFUF the tool to say, hey, this is the directory we're going to be targeting, the root of the web server, and this is the word list we're going to be using to attack it. So we can see next we'll be fuzzing for web directories. The fuzz keyword is mandatory, as it tells FFUF where to target. So we can see here the word list. You don't need the keyword fuzz here, but in the URL you will need it, which is here, as we can see. So we have FFUF tested for almost 90k URLs in 10 seconds, which is very good and much quicker than you normally would be able to manually, as it probably take like 10 years maybe. If you're doing a massive word list and you're doing it manually, it'll take you a very long time, depending on your speed. So this speed may be dependent on your internet speed and the ping if you use FFUF on your machine. So we can even make this go faster in a hurry by using T20, which is like 20 threads. But we would recommend not using it, as you may actually like crash some servers that haven't been like configured properly for load balancing. Pretty much on a real pen test, don't use T20, or even on any machine that you think may crash the server. So this can create server issues and be bad if you're doing this in a penetration test. Normally you just let it run normally, no T20, as you might crash the actual thing, which is not something you want to be doing. You can see here the directory does not have a dedicated page, but shows that we have access to it, as we do not get the HTTP code for a phone not found or for a theory denied. Next session we'll be looking for pages under this directory, see if there's really hidden any pages. So in addition to the directory found above, is there another directory found here? You can see I've done this, but I'm gonna teach you how to find this. So we're gonna let this spawn in, and we're gonna use FFUF w user share seclist. And we're going to be using we're going to not use seclist, we're going to use word list, and we're going to use dirbuster, and we're going to use directory small. You can see here that I don't know the syntax by heart, so I'm just tabbing to just show what I can enter. So we can see here small.txt is what we're going to be using. We're going to next be putting in our URL. We can see here. So I'm going to put in HTTP and the URL. Well, you know, the IP address and the port of the actual server we're going to be targeting. And we're just going to be pressing enter, and we're just going to let this run. We can see we're just getting some random stuff here as well. This is pretty much, we aren't filtering our output, and one thing that I would say, you should filter your output, as it'll get rid of a bunch of random stuff. So if we do filter size, which is FS, filter size 8 well 986, which you can see here. So we're just gonna put space here because we can tell that we're getting some good output, but we're getting a bunch of like trash. So we just want to filter that out, and we can see straight away we get blog and form. So I'm gonna end this, and you can see that's the first thing we need to enter here. So we're gonna move to the next thing right now. So we're gonna let this load, and we can see page fuzzing. Now we understand the basic of FFUF through the utilization of keywords and word lists. We learn how to locate pages. So we can do extension fuzzing. In the previous section, we had access to blog, which is a directory, but the directory returned an empty page, and we cannot manually locate any links or web pages. So we'll once again utilize the web fuzzing to see if the directory contains any hidden pages. However, before we start, we need to find out what pages the website uses, which you can see HTML, ASPX, and HTTP. Well, yeah, PHP. A common way to identify is just guessing this from the HTTP response headers, guessing the extension. For example, if it's Apache, maybe PHP, ISS, which is like Microsoft. It could be ASP or ASPX, but this isn't really that accurate because you can normally use any, well, extension for anything. Like, it wouldn't be that accurate, but it's better than just nothing, I guess you could say. We can see we can utilize FFUF to fuzz the extension, similar how we fuzzed the default directories, but instead of placing the fuzz keyword where the directory name would be, we would place in the fuzz extension to the word list of common extensions. So we can utilize this on checklist, but we don't do this. You don't need to. This is like unneeded. You don't need to do that at all. I don't know why it wants you to do that, but you don't really need it in a real world scenario. Before we start fuzzing, we must specify the extension that we would like at the end of. So we can always have two word lists and have a unique keyword for each, like fuzz1, fuzz2, to fuzz both. But however, one file can always find most websites, and you'd mostly just do one at a time. I don't see the point doing two at once. It's a bit of a waste, my opinion. So we can see one file always finds most website, which is indexed. Index is normally in HTML. Most websites in web development start with index.html as your root of the website. So if you land on a web page on a website from Google, you're most likely going to land on index.html. But you could also land on index.php or another hidden website, well, another hidden index extension website. So we can utilize it on our file and extension fuzz on it. So we're fuzzing for extensions, which we can see run for the fuzz keyword in the extension of the index. So we can see here the blog directory and index.fuzz. And we can see we're using seclist discovery web content extensions.txt. This may be different for you because for me it's user shared seclist. But we're going to go down. And we can see we get a HTTP code 200, which shows us that this does exist. 403 I think is forbidden, so we don't have access to that. So we can see we get a hit, which is HTTP, which gives us 200, which is good, so we can do that. And we can see page fuzzing now. Same context with the keywords, where you be using fuzz, use PHP as the extension, but place fuzz keyword where the file name should be. So we know that there's a .php file on the server, but we do not know the file name. Well, the file name or the directory name, you could say. It's mostly the page name. So we don't know. So we can see here, they've run a scan on this little website here. I mean, they found something here, right here. We can get a couple of hits. Both have HTTP code 200, which meaning that we have access to them. PHP has the size of 0, which indicates that it's an empty page, while the other does not, which means that it does have content. We can visit the sites to verify this. So if you learn to fuzz the directory to find all pages, one of them should should have the flag. What is the flag? So we know that there is a .php file from up here. So next thing we could do, we could just scan for PHP files. It's good practice, and there's no harm in doing so. We're gonna do user share seclist this time. We're gonna be using seclist, and we can see it's gonna be web content and web extensions. So if you don't know the spelling, you can just do this, and there should be discovery web content and extensions. Yeah, you can see here there's a lot. So we're just gonna use a web extensions. It should be web extensions.txt, so this will just be the normal one here. And now we want to check the URL. So you want to do the same thing as before, HTTP to tell it it's a website. It's not it's not an encrypted website, it's unencrypted, so it's HTTP. So we're going to put this in. We got the IP address, the port number, which is very important. We know it's going to be in the blog directory, so we're just going to do blog, and we're just going to copy this right here. We're going to do index, but fuzz. We can see this here. Well, right here, technically. So we're just going to be checking for this first. Let's see what we find. So we can see we find nothing at all. Oh, wait, never mind. We find two things. So we get 403 forbidden. We get this, so we can't access this, which is not fun. But there are ways to bypass this. But we get 200 for here, so we know we can access that. So we're going to be doing the same thing before. We're just going to be scanning this. So we're just going to do FFUF, well, fuzz. FFUF. Well, the word list. User share. If I keep forgetting to put, the slashes. We're going to do user share. Word list. The booster. And we're just going to change this from... Let's see, is the IP address right? It looks like it is right for me. Yeah, it is. So we're going to go back up. We can go back up to here. And we can see that we do have access to a .php website. So we're just going to put fuzz. And we're just going to put .php as we know we have access to that. So we're just going to press enter. And we can see we're getting a random bunch of bloat as well. So we're just going to do filter size 986. I'm going to press enter. And we're just going to let this run for a bit. This may take a while or may not take any time at all. But it normally does take a while to do anything. My apologies, I've done something wrong. We can see here it's going to be blog. Errors happen normally even to the best of us, so it's nothing really we worried about. Just as long as you don't mess up the IP address, you're kind of okay. But if you mess up the IP address, you might actually get into some trouble, so I'd be careful to make sure you get the IP right. We can see we get home, and we can see we get something with a lot of size 0. We can get rid of this by doing filter size 0, so we're going to filter by everything that has the size 0. We can see we get home straight away, so we know there's a thing called home. So if we go here, and we look at the website, we copy this, and we just put home, where there should be fuzz. So let's open this in a new tab. And we can see here, fuzz. Let's put this to home. Let's see what's home. And we get brute force for common passwords. We've done that, so this one is done. And let's move on to the next one. I'm going to end this, as I don't want to waste my CPU and memory. So let's do the final one, recursive fuzzing. So we can see recursive fuzzing. So far we have been fuzzing for directories and then going under these directories and fuzzing for files. However, if we had dozens of directories, which is common on big web servers, they will have subdirectories and subfiles, which will take a very long time. We can automate this by using recursive fuzzing, which is pretty much it's just going to automatically look for files within a file. So it finds one directory and it'll start looking inside that directory without you doing anything. But this can take a while if it's a big website, so you kind of want to use a more precise approach. But if you have time on your side, you can just do the automated scan. But one thing I'll say, the bigger the scan, the louder the footprint and the louder the noise. And you're more likely to get picked up by the blue team or get picked up in Apache logs, which, isn't fun if you're trying to be sneaky about penetration test. So we can see recursive flags. When we start scan recursively, it automatically scans another scan. It automatically starts another scan under the newly identified directories until it has fuzzed the website of all its subdomains. Subdirectories. So we can see here some websites have a big tree of subdirectories like user login, content, and upload, but this will take a very long time to scan. So it's advised to just put depth, which is like how deep will you scan in. So we can see that it will not scan directories deeper than the depth. So we can see the depths here. We can see fuzz. We can enable recursive scanning with the recursion flag. This will just tell FFUF to just recursively scan, and the recursion depth flag will just say, I want you to recursively flag for depth of 1. So it'll find all the directories and it'll only go search the first subdirectories within it, so it won't go too far deep. So we can fuzz the main directories and the direct subdirectories, and if there's any subdirectories of the subdirectories identified, it won't fuzz for them. So it'll only really go this deep. So it will find the root and it will only find these two here. because this is the first thing, and it's going to recursively scan inside of it, but it's not going to scan for anything else within them. So we can see using recursion in FFUF, we can do -e for extension and for .php, which we can find .php files. Finally, we can add the v flag to show the full URL, which can be quite useful, especially if you have a lot of files that you're scanning and you don't know where they're located, especially. So let us repeat the first command we use and add a recursion flag to specify .php as an extension. And we can check here recursion def1 and e for the extension and v for the full URL. And you can see here it's popping out the full URL. As we see this time, the scan took a very long time, 6 times number of requests. So this is going to take a very long time. So maybe 10 or 15 minutes, maybe longer if you have a more of a slower laptop. So we still get a large number of requests, including all the requests we previously identified, with all the single line command. So we're going to just get the IP address, and you can see here it wants you to recursively scan. So try to repeat what you've learned so far and find more files and directories. One of them should give you a flag. What is the content of the flag? So all we're going to be doing is a recursion scan. So let's do this again. So let's go to FFUF, and we're going to do user shared word list directory. We're just going to use dirbuster, as that's normally pretty good. And we're going to, let's get rid of this, and we just want to fuzz here. Always got to check if the IP address and the port is the same, as sometimes they may change in between instances. Very rare, but it could happen. But we can see right now it's the same, so nothing to worry about. And we need to use the recursion flag. So we can see here, recursion, def. So, say if I don't know any of these things, let me just end this straight away. I can do FFUF.h for help. What do I need to do? We can add the things here. So we're going to keep scrolling up until we find something we find useful. We want to do recursive scanning, so we're going to need to look for some flags. We can see one useful one here, v to show the full URL. But that's uppercase, we want lowercase v, to do different things. So we can see recursion. We can see even more recursion strategy for greedy recursive, or at least scanning all the machines, but let's just keep it simple for now. And we're going to get the def, and we're going to set that at 1. So let's look for the def in the machine. So recursion def, we're going to put that in, and we're going to set that to 1. And we put e for the extension, and we're going to put .php. And if we look here, that's everything, and v for the full URL, lowercase, not uppercase. And let's start fuzzing. We can see that we're getting a bunch of stuff. And we can see again, we're just getting a bunch of random stuff. So we're going to need to filter the size as well. I don't know why they're not telling you to filter the content for random stuff. You can see here, this is just a bunch of random stuff. So if we do filter size, 896, well 986, you can see we're getting a bunch of things that may seem interesting. So we're just going to let this run for a while. It may take a long time, so just take your time with this. It won't be quick. So if we have a look at the scan, we can see we found something in this directory, the form directory, and we can see we have flag.php. And if you have a look again, we can see we could have done some better filtering by filtering the size of 0, as it told us earlier that everything with the size of 0 is pretty much has nothing inside and is pretty much useless to us. If I just keep scrolling up, you can see we found loads of empty directories. So we could have done next time is filter by 986 and the slash to, so we could have added a 1 here, and it would have, a 0 to filter by the size of 0. So if we go back down and we quickly just get this IP address here and we put it in, we can see we get the flag as well. And that's pretty much this part of the room done. We only have these 2 rooms these 2 parts left to do, and I'll probably have them out by the end of the week. This probably should be coming out by tomorrow and the day after that. So thank you for watching.